Hey guys, so we're going to be going over Module 9, right? So I'm actually going to break this apart into 3 different parts. So our first part is going to be K versus Q, what we're going to be talking about today in this video. But we're also going to be talking about La Chatilla's principle. And lastly, we're going to be talking about is Bronsted acids and bases. So what I'm going to be going over today, like I said, is K versus Q. So that's what I'm going to be going over about. So I'm going to go over real quickly of what's the difference between K and Q and how to solve these types of problems. So what is the difference between K and Q, right? So what we kind of knew from previous modules is that the equation for K was products over reagents. So let's say C and D divided by A and B, right? And so remember that K is a constant, and so kind of like just think of it as a Kc. Kc is a constant for equilibrium. So remember that it's only at these conditions that these concentration has to be in order to calculate Kc. But with Kq, as you might have noticed into the workbook, is actually has the exact same equation, which is products over reagents. And so you're saying, so what's the difference? So while K is only at equilibrium, K is evaluated into any other condition. So literally at any other time besides equilibrium. So most of the time, they're going to give you initial condition or just anything else besides this one. So that's really the main difference between K and Q. But what's kind of important about learning about these is that most of the time you're going to be comparing these two together in order to know, is it going to be shifting to the right or shifting to the left in order to establish equilibrium. And so there's going to be a little chart that you have to kind of know about, and it's really going to help you out into kind of figuring out which is which. So Q is on the left side, while K is onto the right side. And so when Q is greater than K, try to think of this as like a little Pac-Man, and it's going to be eating Q, which means that it's going to be shifting to the left. So what happens if Q is less than K? Then this Pac-Man is now going to be going this way, which means now it's going to be shifting to the right. But what if they're both equal to each other? Then that just simply means that since K is a constant of equilibrium, that means since both of them are balanced, that they are at equilibrium, and that means that there is going to be no shifting whatsoever, or just no change. And so knowing this chart is going to be a little bit helpful into knowing which is which. So we're going to be doing a few problems about this and so forth. But first, I just do want to clarify what they mean about shifting to the right and what they mean about shifting to the left. And so I'm more of a visual type of person, so I'm going to kind of give you an example of a scale. So let's say we have this ugly looking scale because I can't draw. And so we have, let's say, this general expression of A and B going to C plus D. And so on this side, we have our reagents. And over on this side, we have our products. So I'm going to be kind of coordinating each one. So let's say A is B. Blue is A, green is B, C is orange, and that D is black. And so what if at the beginning everything is balanced? You know, there's one of A, there's one of B, there's one of C, and then there's also just one of D. Everything is balanced. You know, they're both the same, nothing is happening. But what happens once I start increasing the concentration of A? That means I'm going to be adding more onto the scale. And so what happens is that A is going to make this a lot more heavier. So what that means is that how the scale is not going to kind of look like is that since we're adding more A, now it's going to be weighed here on the bottom, while just going to be a little bit more lighter. So let's say we had, I increased A, we had some B's, while over here we just had that one C and that one D, right? So in order to get them back together to the same level again, there's 2 things that we're going to have to do. one, we're going to have to decrease altogether the reagents while increasing the total of the products, right? So since this has more, we're going to be shifting to the right. So that's what that kind of means. Shifting to the right means increasing more of the products while decreasing reagents. The opposite way is that if you're going to the left, that means you're going to be decreasing products while increasing reagents. So that's kind of like a general explanation about what it means to shift to the left and to the right. Because some questions might ask you kind of like which variable is going to increase or decrease or so forth. So that's kind of like what they mean by that. So let's just kind of do a problem first. So this is going to be on page 186, and I'm going to be doing number 1. So in your workbook, it says that you have 3a plus b is going to c. So they do give you a Kc value, which is 3.2. And they do give you another set of concentrations, which is A is 0.5, B is 1.3, and C, which is 0.4. And so you can kind of tell that these are the values for Q because you know that they already give you a K, so these have to be at Q because these are at a different point of time. So they're just asking you which ones are going to increase and decrease in concentration. So first we have to calculate Q. So Q is products divided by reagents, so that means it's going to be C divided by A, remember cubed, and then B, right? And so we do know that C is 0.4, A is 0.5 cubed, and then 1.3. So what you guys get with this and what I got was 2.5. And so we do know our K and we do know our Q. So let's now just compare the two of them. So we had a Q and we had a K. So the Q that we calculated was the 2.5, while K was the 3.2. So looking between these two numbers, we know that 3.2 is greater than, so in this case, Q is less than K. So because of this Pac-Man is going to be going this way, which means that now it's going to shift to the right. So remember, when we're shifting to the right, that means that we're going to be increasing products. So in this case, we're going to be increasing the concentration of C while decreasing the reagents, which in this case is decreasing A and B altogether. So that should be your answer towards that. So I'm going to just be going over one more problem, and this is actually from an exam question from Dr. Nadian, actually. And so what they do is first they give you this equation of PCl3 plus Cl2 is going to PCl5. And so what they do tell you is that you do have a Kc value of 24.3. And do say that under certain conditions where PCl3 is 0.10, Cl2 is 0.15, and PCl5 is equal to 0.60, which of the statements is true. So before we go on to the multiple choice, first we need to calculate what Q is. So we're going to have PCl5 on top, and then PCl3 and Cl2 on the bottom. So we know that it's going to be 0.60, 0.10, and 0.15. So when you calculate this, I got 40. So remember, now we just need to compare. So we have Q, that's 40, and we have a K, that's 24.3. So since 40 is greater than, Q is greater than K, which means now it's going to be shifting to the left. And so remember, when it's shifting to the left, that means we're going to be increasing reagents, which in this case is going to be PCl3 and Cl2, while decreasing products, which in this case is just going to be the PCl5. So now let's look one by one at the multiple choice so we kind of see which is which. So to kind of see what they kind of gave us so far, we know this, and we know that Q is greater than K. So let's look at number A. So number A is that, so this means that it's at equilibrium. But remember, as I said before, this only happens when Q is equal to K. But in this case, it didn't happen, so A is out of the question. But B, so what it's saying is that the reaction will proceed in the direction of forming more PCCl5 until equilibrium is reached. So if you kind of think of it, PCl5, increasing it, is kind of like the same way of saying that it's going to shift to the right. So the next part is C, which means that the reaction will proceed in the direction of forming more PCl3 and increasing more of Cl2 and until equilibrium is reached. So you can kind of think of this as that it's the same as saying that now it's going to be shifting to the left. And D is just none of the above, so we could just also disregard that. So what we kind of know already, and something that you already kind of answered, is that since Q is greater than, it's going to be shifting to the left. And we also know that because remember, when you're shifting to the left, you're going to be increasing reagents, which is our PCl3 and Cl2, while decreasing PCl5. So in this case, the answer would be C. So if you have any more questions about K versus Q, please contact me during like my office hours or anything like that. Other than that, I hope that this was helpful and I hope you have a good day.